FlashGenius Audiobook Introduction, NVIDIA Certified Associate, AI Infrastructure and Operations, NCA AIIO. Introduction. Let's decode the cloudy world of AI infrastructure. Welcome to the FlashGenius's ultimate audio companion for the NVIDIA Certified Associate, AI Infrastructure and Operations Certification, or as we lovingly call it, NCA AIIO. Yes, it's a mouthful, but it sounds pretty cool, right? You're here because you want to go beyond buzzwords like AI, cloud, and GPUs, and actually understand what powers modern AI systems behind the scenes, the gears, wires, and silicon that make the AI magic possible. Let's face it, we all love to talk about smart models and neural networks, but if the underlying infrastructure isn't rock solid, none of it works. It's like trying to run a Formula One race on gravel. So what is this exam all about? The NCA AIIO exam, in plain English. This certification is designed for pros looking to specialize in AI workloads, cloud engineers who want to dive into AI ops, and anyone who's curious about how NVIDIA's cutting-edge tech supports the AI lifecycle from data to deployment. It's like an Intro to AI Infrastructure badge that proves you know how to run, manage, and optimize the hardware, plus software, plus networking, plus security required for modern AI systems. What the exam covers. The exam is divided into several modules and will cover each one in this audiobook. The key domains include AI Infrastructure Fundamentals. What's under the hood? Hardware and system architecture, CPUs, GPUs, DPUs, oh my. AI software stack and frameworks, the code that runs the brain. Networking for AI workloads, making the machines talk. Data management and storage, where the data lives. Deployment and operations, getting models into the real world. Performance optimization and monitoring, keeping everything fast and stable. Troubleshooting and maintenance, fixing the hiccups. Security and compliance, use cases and applications, real-world magic. Exam format and strategy. Multiple choice questions, usually around 45 to 60. Duration, 90 minutes. Format, online, proctored. Passing score, typically 70% or above. But don't worry, this audio guide is built to make every concept stick in your brain. We'll explain things like GPU Direct, Bluefield DPUs, Triton servers, Magnum I/O, and more in a way that's relatable, memorable, and maybe even fun. Think of it as your learning coach in your ears, ready to go, whether you're walking your dog, stuck in traffic, or meal prepping for the week. Tips before you dive in. Don't just listen. Visualize what we describe. If you can, pair this with light hands-on practice or NVIDIA training videos. And remember, you don't need to memorize everything, but you should understand the flow of data through the AI pipeline. All right, you ready? Put your earbuds in, open your mind, and let's start building your AI infrastructure intuition, one module at a time. Next up, AI Infrastructure Fundamentals. Let's roll. FlashGenius Audiobook. Module 1, AI Infrastructure Fundamentals. Introduction. Let's take a quick trip back in time. Imagine it's the 1990s. AI was mostly sci-fi, floppy disks were king, and infrastructure just meant some dusty server room. Fast forward to today, AI is running your phone camera, recommending your lunch, and diagnosing health conditions, all at lightning speed. But here's the kicker. None of this AI magic works without one crucial ingredient: infrastructure. If AI is the brain, then infrastructure is the skeleton. Blood vessels, muscles, and nervous system, all working together to support intelligent function. And as you prepare for the NVIDIA Certified Associate, AI Infrastructure and Operations, NCA AIIO exam, you'll need to know what makes this AI body run. Let's break it all down. Key concepts. So, what exactly is AI infrastructure? At its core, it's the hardware, software, and services needed to support the development, deployment, and management of AI workloads. Let's decode some foundational terms. Compute. This is the processing muscle. Think GPUs, CPUs, and DPUs. For AI, GPUs are the stars of the show. They handle the massive parallel computations needed for training and inference. Storage, where all the data lives. AI workloads often involve petabytes of images, videos, text, and sensor logs. Fast, scalable storage is essential. Networking, how data moves between compute and storage, especially important when workloads are distributed across servers or clusters. AI workload. This refers to the tasks your AI system is doing, like training a model, running inference, or fine-tuning parameters. Scalability. The ability of your infrastructure to grow with demand. More data, more users, more GPUs. Life cycle of AI. AI infrastructure must support every stage, from data ingestion, pre-processing, training, inference, monitoring. Think of AI infrastructure like a kitchen. GPUs are your appliances, fast and specialized. Storage is your pantry. Networking is the kitchen layout, how fast you move. AI software is your recipe book. NVIDIA technologies and tools. Now let's talk NVIDIA, because they've built a whole toolbox just for this kitchen. NVIDIA GPUs. You know them, you love them. From A100 to H100, these are built for AI and HPC. They excel at massive parallel processing, which is exactly what training a deep neural net needs. CUDA. This is the programming language for NVIDIA GPUs. It's like the glue between your AI model and the hardware. NGC Catalog, a treasure chest of GPU-optimized AI containers, models, and tools. It helps you deploy and run AI software faster without starting from scratch. Triton Inference Server, an open-source tool that lets you serve models quickly and efficiently in production. It supports multiple frameworks like TensorFlow, PyTorch, ONNX, and more. Magnum I/O and GPU Direct. These technologies ensure that data moves fast between components. Think of them as your AI kitchen's express lanes. NVIDIA Base Command, a platform that manages GPU clusters, tracks experiments, and helps you run training at scale. Think DevOps, but for AI. Practical applications. Let's make this real. In healthcare, AI infrastructure enables radiology models to scan thousands of MRIs using GPU clusters, fast SSDs, and Triton to deploy the model securely to hospitals. In autonomous vehicles, infrastructure must process sensor data from multiple sources in milliseconds. That requires ultra-low latency networking, robust storage systems, and edge GPUs. In gaming and media, real-time inference powers everything from deepfake prevention to voice synthesis, all using compact distributed AI setups. Use case takeaway. The infrastructure stack is never just one piece. It's a collaborative orchestra of compute, data, and software components working in harmony. Best practices and pitfalls. Best practices: always match hardware to workload. Don't overkill with a massive GPU for a tiny model, or under-provision for training transformers. Use the NGC catalog to fast-track your setup. Monitor GPU, storage, and network usage. Imbalance in any area slows everything down. Common pitfalls. Ignoring storage bottlenecks. If your data can't reach the GPU fast enough, it's like a chef waiting on ingredients. Underestimating power and cooling needs. AI workloads are hot, literally. Thinking of AI infrastructure as static. It's not. It grows, evolves, and needs ongoing optimization. Remember, even the fastest GPU is useless if your storage or network can't keep up. Quick recap and memory aids. Let's hit the highlights with a few catchy phrases. AI is the brain, but infrastructure is the body. Your GPU can't help you if your network's asleep. Infrastructure is your AI kitchen. GPUs cook, storage stores, networks deliver. Fast data plus smart compute equals real AI acceleration. And don't forget, it's not just about building infrastructure, it's about balancing it. Practice question. Question: which of the following best describes the role of AI infrastructure? A. A software framework for writing machine learning code. B. A data model used in AI training. C. A combination of hardware, software, and networking that supports AI workloads. D. A storage solution for neural networks. Answer: C. A combination of hardware, software, and networking that supports AI workloads. Explanation: AI infrastructure isn't just about one piece. It's the entire system that allows AI models to be developed, trained, deployed, and scaled efficiently. Wrap up. And that's your high-speed tour through AI infrastructure fundamentals. You now understand what powers modern AI behind the scenes, from the muscle of GPUs to the storage where data lives, the networks that connect it all, and the tools that tie it together. Next time you hear AI infrastructure, think of it not as boring back-end stuff, but as the engine room of innovation. Without it, your AI is going nowhere. FlashGenius Audiobook. Module 2. Hardware and System Architecture. Introduction. Imagine you're about to build a supercar. Would you start with the leather seats or the spoiler? Nope. You'd start with the engine, the chassis, the suspension, the bones and muscle that make it move. In AI infrastructure, hardware and system architecture are that engine and frame. This module is all about the physical components and how they're connected. The blueprint that makes your AI system not just work, but fly. Whether you're dealing with a local server, a cluster, or a cloud-based setup, understanding the architecture underneath is key to building and operating efficient, high-performance AI environments. So buckle up, we're going under the hood. Key concepts. Let's define what we mean by hardware and system architecture in the AI context. It's not just about picking a GPU and plugging it in. It's about designing a balanced, scalable, and interconnected system that supports massive amounts of data processing, high-speed computation, and rapid communication. Here are the key hardware players in your AI dream team. CPU, the generalist. Think of the CPU, Central Processing Unit, as the project manager. It handles general tasks, coordinates operations, and manages workloads. But it's not built for the heavy-duty, math-intensive work that AI demands. GPU, the specialist. Now enter the GPU, Graphics Processing Unit. This is your AI athlete, designed to perform thousands of computations in parallel. Perfect for matrix multiplications, deep learning, and running AI inference models. NVIDIA GPUs like the A100 or H100 are optimized for tensor processing, FP16, and INT8 operations, multi-instance GPU, MIG usage. More on that in a second. DPU, the offloader. The DPU, Data Processing Unit, is the unsung hero of AI architecture. NVIDIA's Bluefield DPUs are designed to offload non-AI tasks like networking, storage management, and security from the CPU. You can think of DPUs as specialized assistants that free up your main compute engines, CPUs, GPUs, to focus solely on AI. System architecture components. Let's zoom out and look at the system-level architecture. Here's what makes a complete AI hardware platform. Motherboard holds all components together. PCIe bus connects GPUs, DPUs, and other accelerators to the CPU. NVLink, NVIDIA's high-speed interconnect between GPUs. Faster than PCE and critical for multi-GPU setups. Memory. You'll have system memory R, AM, and GPU memory. Big models equals big memory needs. Storage, SSDs, and NVMe drives. Faster drives mean faster data reads during training and inference. Cooling and power. Don't overlook this. AI hardware runs hot and consumes a lot of juice. GPU configurations. Some AI systems use a single GPU. Others might have 8, 16, or even 256 GPUs connected in racks or pods. These can be standalone GPUs in workstations, PCIe-based GPUs in servers, NVLink-based multi-GPU nodes, DGX systems from NVIDIA, pre-built supercomputers for AI. Oh, and remember MIG, multi-instance GPU? It lets you partition one GPU into multiple logical instances, so you can run several models on the same card. Super efficient for multi-tenant environments or smaller jobs. NVIDIA technologies and tools. Let's break down some NVIDIA-specific magic that supports hardware and architecture at scale. NVIDIA DGX systems. These are NVIDIA's purpose-built AI machines, like the DGX Station or DGX 100. Each one packs multiple high-end GPUs, NVLink, tons of memory, and high-speed networking into a single box. Use them for research, training large models, enterprise-scale inference. NVLink and NV-switch. NVLink connects two GPUs directly, but NV-switch takes it further. Many-to-many communication, ideal for deep learning clusters. Think of it as multi-lane expressways between GPUs. No stop signs, just blazing speed. MIG, multi-instance GPU. Partition, a single A100 or H100 into multiple logical GPUs, each with its own memory and compute. This lets multiple users or models share the same GPU without stepping on each other's toes. NVIDIA Base Command and Fleet Command. These are management tools that help you run and monitor DGX hardware, manage workloads, and even deploy at edge locations. Think of them as mission control for your AI data center. Practical applications. Now let's look at this in action. Healthcare AI training. A hospital is training a large image recognition model for diagnosing chest X-rays. The data's huge, so they use a DGX A100 system with multiple GPUs and NVLink interconnects to process everything in parallel, cutting training time from days to hours. Autonomous vehicles. Each autonomous car generates terabytes of data. NVIDIA's Jetson platform for Edge AI, combined with DGX backend clusters, creates a cloud-to-car AI pipeline. The Jetson gathers data and sends it back to the DGX system for model training and updates. Industrial revolution. In manufacturing, edge devices powered by NVIDIA GPUs perform real-time object detection and quality checks, all while syncing data to central GPU clusters via NVLink and NVSwitch architectures. Best practices and pitfalls. Best practices: choose the right GPU type for your workload. Inference equals smaller GPU, training equals beefy GPU. Use NVLink or NVSwitch for multi-GPU training jobs. Leverage MIG for better GPU utilization when dealing with smaller workloads. Always plan for power, cooling, and rack space. AI infrastructure isn't just plug and play. Pitfalls to avoid: underestimating memory needs, running out of GPU memory mid-training. Not fun. Bottlenecking your GPU with slow storage. Forgetting DPU offloading. Your CPU shouldn't be stuck handling networking. Quick recap and memory aids. Let's wrap it up with some brain candy. The CPU thinks, the GPU learns, the DPU clears the way. NVLink is the gossip line between GPUs, fast, direct, constant. MIG your GPU, slice and dice for efficiency. Cool it and fuel it. Your hardware won't run hot forever. And always remember, in AI infrastructure, balance beats brute force. It's not just about the fastest GPU, it's about how well everything works together. Practice question. Question: what is the primary role of NVIDIA Bluefield DPUs in an AI infrastructure? A. Running AI training workloads. B. Rendering 3D graphics. C. Offloading networking, storage, and security tasks. D. Partitioning GPU memory for multi-tenancy. Answer: C. Offloading networking, storage, and security tasks. Why? DPUs handle the non-AI overhead, freeing CPUs and GPUs to focus on computation and learning. Wrap up. And that's a wrap on hardware and system architecture. You now understand how AI's brain and body are built, from blazing GPUs to clever DPUs and everything in between. This is the physical layer that supports everything from autonomous vehicles to chatbots. Without good architecture, AI systems stall. With it, they fly. Coming up next, AI, software stack, and frameworks. How we bring this amazing hardware to life. Let's keep building.